everyone, for today's lesson we are going to be discussing slope and midpoint. So just to discuss slope and what slope is, we know slope as rise over run or the change in y over the change in x. So our first question, we're going to give you this line over here. We just asked you to find the slope of the line. Slope is also represented by the variable m in the y equals mx plus b form, or in that point slope form. So to find slope, if we do the change in y over the change in x, the change in y means we always start at our leftmost point. So if I look at this line, my leftmost point is the point 2, 1. And y, the y-axis, goes up or down. So I go from 2, 1, 2, 3, 4 by going up 3 and then over 1. So a slope of up 3 over 1 is just a slope of 3. So to find slope, there are actually two ways. We can either plot and count boxes, meaning we can plot our points and then either go up or down and always to the right. Remember, you always want to start at your leftmost point. So you don't want to start at 3, 4 and go to 2, 1. We just want to start at the leftmost point and either go up or down and always to the right. If your slope goes up, then that's positive. If it's going down, then it's negative. Okay, so you can plot and count boxes, or you could use your formula, which would be change in y over change in x. So you subtract your y values and then you subtract your x values. But what's important is you have to be consistent as to what y and x value you start with. So for instance, over here, if I were to do change in y over change in x, if I started at the point 3, 4, and I did 4 minus 1, I would have to then do 3 minus 2. I couldn't do 4 minus 1 and then 2 minus 3, right? So if you start at this for x and y, you have to stay there. Something that you always want to kind of keep in mind is that negative should never be on the bottom. So you should never have a negative in the denominator. It should always be on top or in front. And that will also help us when we get into directed and divided segments. So just kind of keep that in mind. All right, so let's just look at a couple of examples. And I actually did the examples using two different methods, both plotting and using your formula. So if you had to use the point 2, 3, so here's 2, 3, and then 5, negative 2, here's 5, negative 2. To find the slope, we can either count boxes, so left to right. So here's my leftmost point. I would go down 5 over 3. So if I'm going down 5 over 3, that's a negative 5 thirds, or negative 5 over 3. Just to show you, you can also use that formula, change in y over change in x. If you're going to use change in y over change in x, we look at our y values. So we have this negative 2 minus 3 right here over 5 minus 2 right here. Either way, we get a slope of negative 5 thirds. Now just keep in mind that slope being positive or negative should make sense in terms of also graphing. I can tell that this is a negative slope. Okay, and with that being said, actually, just to quickly go through your different types of slope, we have positive slope. So remember, left to right always. So this is like going uphill, so that's positive. Left to right going downhill, it's negative. When you have this like horizontal, vertical line just going up and down, that's known as a no slope or an undefined slope. We also discussed if it is just this horizontal vertical line going up and down, it only goes through the x-axis. So a line like this would have an x equals some number sort of equation. I show you here that I kind of remember it's no slope by making this into like a little n for no. And then this horizontal line over here, right, would just be a y equals number. That's your zero slope. Okay, so no slope and zero slope. You should be pretty familiar with your different types of slope. You had gone through them in prior years of math, but we just kind of wanted to sum it up for you right here. Okay, so the next thing that we kind of use slope, or we could use slope to help us find, is the midpoint. Now remember, you can only find the midpoint of a segment. You can't find the midpoint of a line. And the reason why is because lines extend indefinitely in both directions, where a segment has a defined start and end point. So if a line doesn't have a given distance, then you can't find the middle of it. Unlike a segment, if it's a given length, you can then obviously find the middle. So think of it as the middle or halfway. So we plot our points for -4, which is right here, and then 6, 8, and which is right here. And what I did was I just found the slope. So slope here, left to right, is up 12 over 2. And I knew if I wanted to go halfway, that means I had to go half of 12 and then half of 2. Well, half of 12 is 6, and half of 2 is 1. So if I went half of my y distance, which is 6, and then went half of my x distance, which is 1, I get this point right here. And that point actually lies on the line, and that actually is the midpoint. So the midpoint here is 5, 2. Okay, so you can think of midpoint by using slope. Go half of your distance for the x and the y, and it should bring you onto your segment. Now suppose I did half and somehow I got a point that was, I don't know, right here. This wouldn't make sense for 2 reasons. 1, a midpoint must actually be on the segment, and 2, I mean, does this even look like it's half the distance between this point and this point? And the answer is no. So sometimes if it's a multiple choice question and you can't remember, you could always plot your points and say, well, which one appears to be the most accurate? Okay. Now, like slope, there's actually a formula. So there's 2 ways. A formula for a midpoint, and if you think of it as like the middle, you could think of it as like the average. So you could take your x values and add them and divide by 2, and then take your y values and add them and divide by 2. So essentially you could find the average of the x's and the average of the y's. Or, like I just had explained, you can find the slope, divide by 2, and then move from your leftmost point with the new slope. Okay, so 2 ways to find midpoint of a given segment. All right. So here, find the midpoint of the segment whose endpoints are 3, -4, and 6, 10. So we plot 3, -4, we plot 6, 10, and I'm going to show you both ways just so you have an idea. So first, if I use my slope, I went up 14 and over 3 to get from one endpoint to the other, left to right. So if I want to find the midpoint, I have to go halfway. So it means I'm going to go up 7 and then over 1.5, which is interesting because 0.5, which that's okay. And I get this point right here. So this point right here is actually 1, 2, 3, 4.5, 3. So I get the midpoint of 4.5, 3. Now, using the formula, I should get that same point. So if I kind of just rewrote my x and y values over here. So here are my 2 points. So take the average of the x's. So 3 and 6 is 9. Half of 9 is 4.5. Then I take my y's. -4 and 10 is 6. Half of 6 is 3. So yep, I get 4.5, 3 that way as well. So there's another example of how to find midpoint. Okay. Now we're just going to do 2 more examples where we're going to use the idea of midpoint, but maybe not exactly use the same formula. So let's take a look at number 5. So number 5 says the center of the circle is -2, 9, and the endpoint of the diameter is 3, 6. So they want the other endpoint of the diameter. So here's the center, here's the diameter. And you can think of this in terms of what we, when we use our compass, and let's see if this actually works, and it should. Oops, let me just get over here. So if you remember, when we use our compass, if I put my needle here and I flip this around and I open it up, okay, so center, endpoint. And I have to find the other endpoint. I'm just going to kind of swing a circle. I know the other endpoint should not continue down here, right? This is the center. The other endpoint of this essentially diameter should be over here somewhere. So how do I find it? So this is how I kind of like to use my slope to help me out. So I know if I'm going from this endpoint to the center, I have to go from the center to the endpoint. So remember, slope is always left to right. So if I'm going from the center to the endpoint, it's down 3 over 5. Now I have to get to the other endpoint, which is on the other side. So I'm going to do kind of the opposite. I'm going to go up 3 and then to the left 5. And I would end up over here. Now notice I just kind of added in my own tick mark. So that's my way to adjust the graph even though I'm off my piece of quote-unquote graph paper. So then that would give me -7, 12. Now the other way to think of this is by what I did over here. So think about this. I start at my center and I'm given an endpoint. So if I want to go from the endpoint to the center to the other endpoint, I'm going to work in the same direction. So if I have to go with my x values from 3 to -2, I subtract 5. Now it has to be the same, right? That distance has to be the same. So if I'm going to go from 3 to -2 by subtracting 5, I can get my new x value by doing that same distance or applying the same distance, so subtracting 5. So -2 minus 5 is -7. Now I can apply the same thing to the y's, right? I went from 6 to 9 by adding 3. So I can go from this center y value to my other endpoint y value by also adding 3. So 9 plus 3 is 12. So again, I get the same endpoint for my diameter by using this method. So our endpoint would be -7, 12. And also, again, keep in mind that there are kind of ways to check, right? -7, 12 is over here, and when I sketched in my circle, it actually ends on the endpoint. If I would get a point over here, let's just say, -3, just, I don't know, maybe 15, that wouldn't make sense, right? For the point to be all the way over here, meanwhile, this is my endpoint and my center, wouldn't give me a diameter. So always keep in mind that although we're using algebra in some way in formulas, that in a sense, just using what you think it should look like and what you know it should look like could also kind of help you out. All right, and then finally we have number 6. So 6 says we have the coordinates of the midpoint is 2, 4, and the coordinates of B are 3, 7. We need the coordinates of A. So same thing like we just did, right? They're giving you a center and an endpoint. You need the other endpoint. So I showed you both ways here. So here's the given center. Here's the given endpoint. We have to find the other one. So from the center to the endpoint, we went up 3 over 1. So I could apply that in the reverse direction. I can go down 3, left 1. And it gets me to this point right here, 1, 1. Or we can kind of work backwards. Take your midpoint that they gave you and the endpoint, and say I went from this y value, 7, to my midpoint, which is 4, by subtracting 3. So to get to the other endpoint's y value, I have to subtract 3 again, and I get 1. The same for the x's. I go from 3 to 2 by subtracting 1. To get to the other x value for my other endpoint, I do 2 minus 1 to also give me 1. So either way, we end up with the coordinates of A at 1, 1. Okay, so different ways to kind of think about this in terms of either doing something by using like a setup, almost like a formula, or plotting points. So to kind of wrap everything up, we are dealing with both midpoint and slope. They both either can be done by counting boxes or by applying formulas. Think of midpoint of your average of your x's and your average of the y's, or finding the slope and dividing by 2, then moving with that new slope. And then just think about slope, as always, rise over run, change in y over change in x. You can plot and count boxes, always starting at the leftmost point, or you could use your formula. Subtract your y values and put that over the difference of your x values. Okay, so there is no formal assignment that goes along with this lesson, but next week you will have a Google Forms. I hope you all enjoy your weekend.